Hi, how are you guys doing? I hope you're well. I still kind of miss you and miss being around hanging out with you. What I want to do is I want to explain to you how to do this lab that I've assigned for you today so that it's not so confusing. So before we go any further, you need to get your lab, and your lab consists of this paper right here, okay, with this on the back, this thing right here. Okay, you also need a pair of scissors. You need a Sharpie or something dark like a marker. You need some tape or a glue stick, and then you need an extra piece of paper. I used colored paper, but you don't have to use that. You can use just plain old white paper. Okay, so what you want to do is you want to pause this until you have that, and then we'll get going. Okay, so on Tuesday, you watched the Ed Puzzle videos on enzymes. And one of the Ed Puzzle videos, your last one, in fact, was on breaking down lactose, or for a person who couldn't, and that was lactose intolerant. So today, what you're going to do is you're going to simulate two enzymes. One enzyme is going to break down lactose, and the enzyme is named lactase. And the other one is going to build sucrose, which is table sugar, from two reactants. So enzymes don't just break stuff down, they actually build stuff up too. And that's important to know. So you're going to be doing both today. So the first thing you want to do is you want to cut out all your pieces. So I cut out all my pieces for my lactose. So when you get done, you're going to have little pieces that kind of look like this. Okay, so make sure you cut those out. And if you want to pause the video until you get those all cut out, that would be fine. Before you go, there are just a few things for you to refresh your memory. Enzymes are really important. We're going to talk about these later. We're not going to really talk about them, but you're going to hear enzymes a lot. And so when you hear about an enzyme, I want you to know what that is doing so that you have that frame of reference. So part A of this lab is just some vocabulary that you've done before. I would like you to go ahead and fill that out and see if you can fill that out without actually using your papers. If you can't, go ahead and use your papers. Okay, so take a second and pause and go ahead and cut out your enzymes. Okay, so I'm assuming that you have all your enzymes cut out. You'll notice there's some enzymes that look like this. They look like a C, a big bubble C. Okay, and you'll notice you have three of those. And then, because here's the third one over here, okay? And then also you have, oops, sorry about that. This is a little bit, you have on this paper, you have three of these here. Okay, now part of this is for you to understand the vocabulary. So if you look, these two right here are called substrates. So you know what a substrate is, the part, it is the actual compound or compounds that the enzyme's actually going to do work on. So in this case, you have two substrates, and in the end, you're going to have a product. So you know that the beginning part of your enzyme, your diagram, you're going to want to have the enzyme and the products in pretty close the enzyme and the substrates in pretty close proximity to show that the substrates are actually going to go into the enzyme. Now, I want you to notice that the substrates and the enzymes are going to fit perfectly together. And that's a very important part of enzymes, is that they are unique to the substrate that they work on. Okay, remember that also right before the enzyme does its work, and this is a very short time, you have an enzyme substrate complex. And so you're going to notice that there is a substrate that has dotted line in it. And what that's going to represent is that the enzyme's actually working on those substrates. And then you're finally going to have the product. Okay, so what I did was I set up my lactose. So I set up the one that's actually going to be, it's going to be splitting lactose up. Okay, so what I did was I cut all these out. So here's my enzymes. Whoops, I can't do this backwards. My enzyme looks like this crown. So I have 1, 2, 3 over here. Okay, and you're going to want to draw arrows. I forgot to draw arrows for these. Okay, so here, up here, it says this is my substrate. So if you read through the lab, you'll notice that the lab tells you that the substrate is lactose. So if it's lactose, then we know that the enzyme has to be lactase, because in almost 99% of the cases, you can tell an enzyme by the last 3 letters. Most of them are ACE, lactase. That makes it easy to understand. Okay, so you'll notice here what I did in the beginning is my substrate's not actually in the enzyme, it's getting there. Okay, and then my second one here, what I did was I put my enzyme and my substrate together. And notice I have that dotted line in here, which means that the enzyme is actually working on the substrate. And I called this my lactose lactase complex, which is actually the substrate enzyme complex. Okay, so then my last part, what I did was I showed over here, sorry, I showed that my enzyme's there, and this is really, really important. Notice that my enzyme at the end is exactly the enzyme at the beginning. And that's what's one thing really cool about catalysts, biological catalysts, which are enzymes, is that they don't get used up in the reaction. And so they can be used over and over and over again until they wear out and they have to be destroyed. Okay, also what I did was I showed that now it is leaving the enzyme because we don't need it anymore. Our products have been broken up. And it doesn't matter which one you label here, because one's going to be glucose, one's going to be galactose. Okay, so what I needed to do here that I didn't is I needed to draw some arrows to show which way this reaction is going. Okay, and so when you look at this, you'll see that I have arrows now. So this is my first one right here, whoops. And my arrow is going to the second one. And this is what's called an intermediate step. You don't really see it in the chemical equation, but we know it's there. And then our third one, my third arrow comes over to here. Let's see, right over to here, and shows our product. Okay, once you get those on your paper, you want to leave enough room so that you can show the chemical equation there. Okay, so here's the chemical equation of lactose getting broken down. So over here on this side, I put my substrate or my reactant. This is what I want to be worked on. It's my reactant. It's always on the left-hand side of this arrow. Okay. Now this won't work unless the enzyme is added to this. Okay, and that's why I put the enzyme drawing an arrow showing that it's going into the reaction. And then here I put this little squiggly arrow to show that for a short little time we had the enzyme substrate complex. Okay, and then on this side, which is the right side of the arrow, we always have the products, and the products here are galactose and glucose. Okay, now that's what I want you to do with that one. And the other one, I want you to do the same thing, except this one, like I said before, is going to build a product out of 2 substrates. And so I want you to try to figure that one out on your own using your paper for that. Okay, text me tomorrow if you don't understand how to do that, and I can give you a call or I can type a little message. But if you follow the directions, they're really, really good. Okay, so part A are those few vocabulary words. Part B is doing your lactase interaction. Part C is you're going to be building sucrose from glucose and fructose. And then part D, you'll notice, is a graph. Okay, now I don't want you to do this graph on paper. I want you to do this on a Google Sheets. And so you should know how to do that now because I taught you how to do that with Edpuzzle. One thing I want to tell you though, so you don't get confused, and you should write this down if you have it right now. Your x-axis is going to be your temperature, and your y-axis is going to be your reaction rate. So when you put these numbers into Google Sheets, you're going to want to make sure that you, at the very top column, you put X and then put temperature and then all those numbers. And then the next column over, you put Y and you put the name, reaction rate, and you put those, put the units and then put all the numbers in. And then what I want you to do is go ahead and just do a graph. And you don't have to do any trend lines this time because this is going to be a bell-shaped curve graph. And from that, I want you to be able to answer this question number 3 right here. Let's see if we can do this. Okay, so it says, what is the optimum temperature for which the enzyme activity is the greatest for this and this reaction? Okay. Temperature is very, very important for enzymes. So when you want a reaction to take place, sometimes the best thing to do is like stir whatever you're working with, or you can chop it up into really small parts and then stir it, or you can add heat and make that reaction go faster. Well, in the human body or in the organism's body, actually trying to heat something up is going to destroy the tissue. It's going to destroy the enzyme and it's going to destroy the tissue. And so we don't want to have to heat it up that much. There is a perfect temperature at which enzymes work. And I think it would be really cool if you wanted some extra credit to tell me what temperature you think enzymes work best in the human body at degrees Celsius. Okay, so if you have any problems, give me a text or give me an email. Otherwise, I will assume everything's hunky-dory. When you're done, go ahead and take a picture of your diagrams like this and upload them, and then upload your graph from your Google Sheets. All right, if you get stuck on the Google Sheets and you can't remember you can go back to Edpuzzle and you can watch that video again. All right, have a good weekend, and I will see you next week.